Good morning, everybody. Thanks for coming along to this session on building high-scale internet-facing websites on SharePoint 2010. How many of you were at the party last night? Anybody? Oh, a lot of you. That's very impressive. 8:30 in the morning. Was it good? I missed it, unfortunately. Only got in yesterday. Anyway, so this session is basically to talk about some of the best practices that the product group and the field consulting have come across over the last couple of years since the release of the product in terms of building a very high scale in terms of throughput environments built on SharePoint 2010. How many of you here are running an internet-facing site on SharePoint today, 2010? So most of you, good. So hopefully some of the material will be familiar to you. Hopefully you'll learn some other things as well. So we'll walk through what are the most common areas of configuration and consideration in terms of delivering high-scale internet sites on SharePoint. We're not going to talk about server configuration tasks, things that we would do to the Windows server to tune them for high scale and those kind of infrastructure topics. It's going to be very much focused on the feature areas in SharePoint that we need to consider, the deployment models we need to think about, and how we configure the SharePoint configuration aspects such as caching and so forth. My name is Spence Harbour. I'm a SharePoint architect based out of Edinburgh in the United Kingdom. I do a lot of work in this field in terms of performing health checks and risk assessments on SharePoint 2010 deployments in the internet-facing scenario. I'm also the content owner and instructor for the WCM portions of the Certified Master course. Okay, so before we get started, I just want to sort of demonstrate briefly a cautionary tale, if you like. What happens when you don't do some of the things that we're going to talk about later on in the session. The site on screen here is the Microsoft Small Business Center. As you might imagine, we can use Microsoft sites as examples. We perhaps couldn't use other people's sites, so we'll stick to our ones, as it were. And this site went live not too long ago, about 6 months ago. And of course, when the site was finished, an email was sent out to the management team saying, "Hey, check out the wonderful work that we've done on SharePoint to deliver this site." And this is what the site's supposed to look like. So the site went live. Everything was okay for a little bit. But then once the site picked up a load and was starting to get visited quite heavily, this was the end user experience. So you can see the bit highlighted in red there is showing a web part error, and it's basically complaining that the solution in place there has already exceeded its usage quota, and that is supposed to be that hero control, that blue banner there, the blue graphic there, which is a client-side control which integrates back to the SharePoint list data. And so this is actually a snippet from an email from a very important person at Microsoft, basically replying to that email saying, well, it looks good, but it's not working. So that was slightly embarrassing. And this is a symptom, the kind of thing that you will see if you don't follow some of the advice and best practices that we'll spend the next hour or so discussing. Now, this is very common, not just across the kind of larger deployments like this, but across the WCM space in general, because it's very easy to get trapped into focusing in on the development work of the solution, and then when it's done, sort of pushing it out without the appropriate testing and capacity planning activities that really underpin these things in production. How many of you here, for my benefit, are developers? About half of you, and the other half, I guess, will be IT professionals or infrastructure people or site designers and so forth. Okay. So before we talk about the configuration that we do in SharePoint, we also need to stress the importance of appropriate capacity management for these solutions. If we're talking about high-scale internet-facing sites, not just Microsoft.com properties, but also some of the larger internet sites that are running on SharePoint 2010, like Ferrari.com, we won't be successful unless we do appropriate capacity management. And you'll note that it's very important to consider this as a management discipline, a life cycle, rather than just a planning activity up front. We need to manage capacity throughout the life cycle of the deployment. Now, if we're not in the business of web hosting, there's only so much of this that we're going to be able to do, of course. If we're involved in the construction of the solution, but we're not involved in the hosting of it, we'll only be able to do kind of the upfront elements of this. Now, the cycle that's shown on the slide there is documented in quite some detail up on TechNet. I'm not going to dive into each one in gory details. But the point I'm trying to get across here is that we need to think about this throughout the life cycle. So we need to do that upfront planning and figure out, what type of environment we're going to need to host the site. We're going to need to have some kind of business requirements drive this, right? We're going to need to have some kind of requirement for the maximum throughput that the environment can handle. Are we going to have, from time to time, significant events that happen within or out with respect to our company that are going to drive significantly additional load into the environment? So, are we planning to make an acquisition? Are we launching new products? Those kind of things. Then we need to architect the solution for scale, and this is perhaps the most difficult one to do for the development teams when it comes to internet-facing sites. We can't simply, take a solution that we build and deploy without considering the things we need to take into account from a development perspective, but also a hosting perspective in terms of high scale. And we'll touch on some of those as we walk through the rest of the material. Obviously, the piloting is important from a functional perspective, and from a capacity perspective, we need to be performing adequate testing to ensure that our scale architecture is correct and so forth before we actually deploy, to the internet. Now, this is quite difficult to actually do. You're never going to be able to test in a test lab environment the same kind of traffic situations that you're going to see on the internet. So you're only going to be able to do this to a certain degree, and then you're going to have to extrapolate out that data to give you an indication of how it's going to perform. You're not going to know until this thing goes into production how well it's going to meet your planning and architecture stuff that you did up front. So that monitor and validate aspect of this life cycle is incredibly important. We need to make sure that whoever's hosting the environment is collecting adequate data and keeps going through and validating that the site is performing as expected. So in terms of an internet-facing site, we're focused very much on a specific workload of SharePoint. As hopefully you all know, SharePoint's got these numerous different workloads, and the performance and scale characteristics of each workload can be very different. If we're building an intranet for social collaboration, we're going to have much more read-write activity than we are on a internet-facing website, which is predominantly read-only, right? The majority of users are coming in and just reading pages. There might be small areas of the site where users log on and contribute content, but for the most part, everybody's an anonymous user, and there'll be a small number of authors who are contributing content on the environment. So that's our workload, very much a read-heavy environment. Then we need to think about our data set, and this is a key planning consideration for WCM sites, especially the larger ones. In most cases, a WCM site is going to be a single site collection. Okay, and that's going to give us numerous benefits, but of course we have scale limitations there, and if we need more pages than the single site collection is going to allow for us, we're going to have to think about how we cross out of that single site collection boundary. So how much content do we have? How frequent will it be updated? And by whom? Are we thinking about doing multilingual? How many of you here have a multilingual requirement for your SharePoint 2010 websites? Yeah, okay, that's a pretty good number. Usually if we give this talk in America, the numbers are a lot less. But anyway, this is a pretty big deal. So we need to think about how we're going to approach the delivery of that. And in the SharePoint world, in most cases, regardless of how we approach the delivery of multilingual, what that's going to mean is a duplication of content, right? So if we've got 5 languages, we're going to have 5 lots of the data. So that's a pretty significant consideration here. As I mentioned earlier, we also need to think about our business requirements or our targets for things like performance, throughput, availability, and so on. So when we're in a WCM site, the key thing that we're interested in is maximizing the throughput as much as possible on the equipment we have, on the hardware we have. And so the basic metric that we're interested in here, whilst there are others, the most important is RPS, or requests per second. The number of requests the machines can deliver concurrently each second. And in order to get high requests per second on a reasonably small number of web servers, we're going to need to use the caching capabilities available to us effectively. And that's the key thing, or the key configuration aspect that's going to allow us to hit high RPS. There's some other things, that we're going to need to think about. So, if the site goes down for whatever reason, what's our recovery time objective to get it back up and running, and those kind of things. But those are really more not related to the delivery of the WCM site. They're related to the delivery of highly available SharePoint generally. So if we take a look at caching and see why this is so important to us, it should be fairly obvious that by caching information, we are going to be able to do more work or respond to more requests than if we're not. But this chart is a very good indication of, or demonstration of that fact, if you like. On the vertical axis, we have the peak throughput, which is really the requests per second. So that's how many requests per second we're able to deliver. And then on the horizontal axis is the number of web servers in the farm. So, the first hit is 1 web server, then we have 2, and then we have 4. And then we have a thing called the output cache hit ratio. Now, we're only focusing on 1 cache here for the purposes of demonstration. There are 3 different caches, and we'll come on to each one in more detail in a little bit. But you can see down the bottom the kind of yellowy orange line there. That's a cache hit ratio of 0%. So that means we're not serving any requests from the cache. So maybe we've turned it off or we've misconfigured it somehow. And you can see here, we're not getting particularly great requests per second here, and there's not that much difference between having 1 web server, 2 web servers, or 4 web servers. We're never going to be able to get, we're not even getting to 1,000 requests per second here. And this is actually surprisingly common when we do health checks to go in and view deployments where the customer complaint is, well, we've got these 4 web servers, which obviously cost a lot of money and everything to purchase and deploy, but we're not getting the throughput we need. And we don't see the value. Why have we got 4? We could have just as well had 2, sort of thing. And then if we look at the next line, which is the purple line there, this is with a cache hit of 50%. Cache hit ratio of 50%. So, we're serving 50% of requests from the cache. And you can see, we're not actually doing that much better there. I mean, it's much more linear in terms of scale. When we've got 4 web servers, we're able to get towards, about 1750 RPS. But it's really coming into, it's really giving us value when we get to the green and red lines, right, which is 90% and 95% cache hit ratio. And you can see that we're now approaching, very much a linear scale. Then if our cache hit ratio is 100%, so everything is being served from the cache, we get a directly linear scale here from, with 1 web server, we're able to do, about 3,800 requests per second, which is a lot, right? Now, you don't just want a single web server, because obviously if that machine has a problem or you want to, apply some Windows updates or something, you're going to have an issue on your website there, right? So we're going to have at least 2, and you can see, with 2, we're effectively doubling the amount of capacity there. And then when the line sort of becomes dashed, is interesting, because from this, at this point in this test, we couldn't actually go any further at this point because the bottleneck becomes the network adapter on the machine. So we can't actually throw enough requests at the machine We can't throw 10,000 requests per second at the machine because the network card in the environment becomes the bottleneck. Now, of course, there are ways to get around those additional bottlenecks, but it demonstrates the effect of output caching on our peak throughput. So the idea is we want to be, somewhere between 90 and 100% cache hit ratio. So the bottlenecks in our environment are potentially many, and they're all the obvious things that you would consider. On our front-end web servers, or what we really should be calling web servers, the standard resources on that machine, CPU, memory, disk I/O, and disk space. The same for application servers, but generally in a WCM scenario, the CPU is not going to be a considerable bottleneck there, assuming we have the appropriate number of them and so on. Then when we get to the database, it's predominantly around disk I/O, database locks, the number of connections we can have as well. But the key one that we're interested in is in our environment, if we're running a high-scale WCM site, the key bottleneck should be the CPU of the front-end web servers. This is the thing that's going to determine what type of caching we can do, and also how we configure those caches to try and get that ratio that we saw on the previous slide. Now, memory is also massively important, and I'll keep coming back to this as we go through the rest of the slides. We shouldn't skimp on the memory in our web servers, especially given how cheap memory is today. The more memory we have, the bigger our caches can be, and the more of the site we can effectively hold in memory. So it should make sense that whilst it's not a bottleneck per se, if we have 4 web servers and they've each got 8 gig of RAM, we're not really getting the benefit of having those 4 machines. We'd be much better off with less web servers with more memory in most cases. So our key tools for scaling in terms of the SharePoint data set that we're dealing with are on this slide. So we've got the output cache, the object cache, and the blob cache. Now, the output cache is effectively the same thing as the ASP.NET output cache, with some additional configuration capabilities for SharePoint. So we add a UI for managing the configuration and also some additional parameters that we can tweak. But fundamentally, what we're doing is once the page has been generated, we will store the output, the resulting HTML, etc., into an in-memory cache on the web server. And so the next time that page is requested, we're not going to go and speak to the database and build the page dynamically at runtime. So the same thing as the ASP.NET output cache. Then we've got the object cache, which is a SharePoint-specific cache, which is used for caching, again, in memory on the web server, the results of queries to SharePoint lists and libraries. So, for example, if we use the content query web part, or the table of contents web part, or custom code that's querying the SharePoint repository, that's going to issue an SP query, and we want to cache the results in memory so that, again, when we reload that web part, maybe on a different page or the same page, we're not going to perform the query directly against the database again. So both of these guys are in-memory caches. One key reason why we need to think very long and hard about how much memory we have in our web servers. And then we have the blob cache, which is also called the disk-based cache, and this is responsible for caching files. So the simple example is, we have a web page that allows us to download product catalogs as PDF files, for example. Those PDF files are obviously blobs in the content database in SharePoint. And what we want to do is we want to cache those on the web server's hard disk, so the next time somebody requests them, we don't have to go back to the database and retrieve the blob, which is quite an expensive operation. And so that is a SharePoint-specific capability that's configured on our web front ends, and it's on each web front end independently. We need to think about that, how we manage the multiple machines. So we need to make sure that we've got enough disk space to hold those cached files. And we also want to make sure that that disk that we're using for the cache is fast, right? The I/O is fast. If we're using some wacky shared storage off the back of the web service for that cache, then we're not going to get the benefit. We need this to be fast, directly attached storage if at all possible. So in terms of configuration, the output cache is fairly straightforward. Within our site collection, the root of our site collection under site settings, we have two links, site collection cache profiles and site collection output cache. And these are the pages that SharePoint adds to the output cache, really, and they give us the ability to configure things in a granular fashion. So we can have a different output cache for our anonymous users as we do for our authenticated users. And in most cases, the authenticated user is going to be the content author or an administrator. And so in most cases, for the authenticated users, we're probably not going to have caching turned on, because in most cases, the content author wants to see, the right now, up-to-date version of the pages. But the point is, we can have different profiles for different sets of users. And this is pretty important if we have an area of the site where people, like a members area of the site, where people might log on to see protected content, or there might be like a forums area of the website and so on. And you're going to almost certainly want to lessen the cache lifetime for those areas of the site. We can also have different behavior for different page layouts. And again, this might be useful to us if we want to have the majority of the site have a very sort of long cache lifetime, but for one area of the site that may be press releases or something like that, we want it to be much more current. We want the content to be much fresher. Then we also have vary by parameters, so we can vary the cache based on different incoming parameters. Might be from the query string, but they might also be other aspects of the system, like the type of user and so on. So we have quite a lot of control here. Having all that control is great, having that flexibility is great, but generally we should be starting with this configuration on this slide, the recommended configuration, if you like. This is our start point. If we need to tweak it later, we can do, but this should be like the initial start point. So we'll use an out-of-the-box profile that's there for us, already configured, called the Public Internet Cache Profile. And what this means is that for anonymous users, we're going to be aggressively output caching. And there's also an option in there called Check for Changes. Now what this will do is, even though the page is cached, we're going to check to see if it's changed. And that in itself is, quite an expensive operation. So this option is not enabled by default. We shouldn't go ahead and enable it. When we're in the screen and we're looking at that option, it sounds kind of good, and it's very tempting to check the tick box. But we should leave this off in most cases, and we should reduce as much as possible the vary by parameters. The more of those we have, the more work the cache has to do to figure out what should come from the cache and what shouldn't. So the fewer of those we have, the quicker everything is. And then for our authors and administrators, the authenticated users, not perform caching at all. So this would be a good start point for pretty much every deployment. Now, just going into site collection settings and turning it on doesn't mean it's going to be working, right? We need to validate that it's actually doing what we want it to. So one of the options we have in the cache settings is the debug information, just a little checkbox there, which allows us to enable the debug cache information on pages. Now this is not going to write anything out to what the end user will see. It's just simply going to stick a HTML comment at the very bottom of the output. You can see there it says rendered using cache profile, and then the name of the profile, and then a timestamp. So we can see when that item that was requested, the page in this case, was first cached. That's quite a long time ago in this case. Now, this is really the only appropriate way to do it. We can't really do anything other than this that isn't then going to, that isn't going to incur additional expense. This is very lightweight, very simple, so it's not putting any overhead on the system. Whereas if we go to other approaches, they will immediately have negative impact on the performance of the site, and so throw the statistics off. Now, if we need to get a bit further into this and actually validate that we're not going back to the database and so on, we might think we could use the developer dashboard here. But we can't, because the developer dashboard's output will be cached as part of the page output cache. Okay, so we could turn it on, and the developer dashboard would tell us for each request that it's going back to SQL Server all the time. So if we want to get into understanding the impact of output cache on SQL traffic, we should be using SQL Server profiling tools for that, rather than any of the things inside SharePoint, because those things inside SharePoint will just be cached as the rest of the pages. Also, you probably don't want the developer dashboard on the site, because it's going to impact the markup and be available elsewhere as well to anonymous users, potentially. Now, we should monitor this during production. I mentioned, as part of the capacity planning thing, how important this is. And the way we will monitor the output cache is via performance counters on the web servers. So there's a bunch of ASP.NET counters and SharePoint counters which will allow us to collect data to understand what our cache hit ratio is. So where that chart came from, the very first chart I showed you, was driven by performance counters that are collected on the web front ends. So if we return a cache miss, so something that isn't cached, that's actually more expensive than rendering the page without caching turned on. So if you remember that very first line in the chart where we weren't seeing much improvement in our requests per second, this is the primary reason why. So we want to make sure we understand what our cache miss ratio is as well, and if that's high, we need to be changing the configuration to remove that problem. Also, if we're trimming the cache, so checking items and resetting them, if that's happening a lot, then again we're not going to get the performance we want. So we want to look at two potential things to fix this. The first one is make the duration of the cache longer, so items stay in the cache longer, so we're not having to retrim them all the time. Or we'll add more memory to the web server so that the cache can include more pages. So when it says scale up the web servers, what that means really is adding more memory into the web servers. So another demonstration from an unnamed site is the effect of requests per second, which again is the vertical axis, or read volume, on the CPU. And here you can see our requests per second is the blue line, which is steadily increasing all the way up to about 3,500 there. And the red line is the aggregate of the CPU utilization on the machine. And we get a similar sort of end result to what we saw in the first graph, as everything's working fine until we hit about 80% of the CPU. Now, when we get to that point, we can still increase the requests per second in an almost linear fashion, but the latency jumps massively at that point. So the takeaway here is, it's perfectly okay for our CPU utilization on our web servers to be, 75, 80%. That's what we want. That's why we brought the machines with those processors. There's no point having, a bunch of processors sat at 30% utilization. That means you've got too many processors. But once we get, past the, 80% kind of area, we need to think about changing the configuration so that we're not increasing the latency, in other words, the time it takes for the end user to receive the page, significantly. We might be able to do lots of requests per second, but if the latency is very high, then all that means is we have lots of annoyed end users browsing the site, waiting ages for the pages to load. So when we talk about caching, and this is most relevant to the object cache, is do we want the content to be up to date or fresh, or do we want our pages to be really fast? And it's commonly viewed that you can't have both. You can't have the best of both worlds. If you want super performance, then you're going to have to make a trade-off, whereas the content may not be as fresh as you might like it to be. Interesting graphics. I'm not so sure some of those vegetables are actually that fresh. But anyway, we can have fast and fresh. We can have the best of both worlds. And it all comes back to understanding, again, what our content life cycle is. So how often is our content updated? And generally, for the WCM site, the vast majority of the information on the site is not going to be updated that frequently. It's not being updated every hour. Of course, there will be elements of the site that are updated every hour, perhaps even more frequently than that. If you have one of these little web parts on the site that's showing a Twitter feed, for example, that could be, being updated, faster than the end user can even refresh the page. So we do need to consider that there's going to be different types of content with different requirements, but we can get to the combination of both. And the way we can do this is by leveraging another ASP.NET capability, which is called post-cache substitution. So the idea here is, for the majority of the page, so in this example, this Quality Food Centers site, our navigation there, the Chrome of the site, these banner graphics in the middle there, all that stuff is going to be cached. But we have this kind of dynamic area here where users sign in, create an account, and then when they're signed in, they're welcomed back and they have different links. That wants to be dynamic, i.e. no caching. So that's dynamically assembled at runtime. And so by leveraging this post-cache substitution capability, we can get the best of both worlds here. Now, of course, there is a performance penalty, but it's only for that small area of the screen. So if we're building that well, we can minimize the impact on the overall throughput of the site. So the way we do this is we'll write a custom control, which would be this little box that's in the red lines there. And if we inherit from webcontrols.substitution, this element of the page will be called on every request. So this would be dynamically created at runtime. But of course, we need to understand what that control is doing and make sure that we're not trying to do too much in it. We don't want to have 50 controls on the page that are using this, right? We only want a couple at most. And we want to make sure that whatever data it is we're retrieving, we're doing so in a performant fashion. In a lot of cases, this data that's in these areas won't be coming from SharePoint stores. It might be coming from an external application. It might be coming from a line of business database system and so on. So we may not be querying SharePoint directly here. So we need to be aware of the latency of those external systems. That's going to be a key dependency on our performance, or for our performance. We also need to think about this scenario where I'm sure you've all been frustrated by websites as a user, where a lot of the work is actually being done on the client, right, in your browser. And so most of the page loads, but there's this little bit down the bottom that's hooking it up to social networks and so on. And until that bit down the bottom is finished processing, you can't scroll and move around the page. So that's another consideration. We might want to look at doing these kind of things using client-side technologies, but we shouldn't forget the end-user experience, even though those technologies reduce the impact, of course, on our SharePoint environment, on our SharePoint servers, it's very easy to fall into a trap of not understanding just how frustrating those can be for end users. And from the end user's point of view, right, they don't care whether it's happening in the client or on our web server. As far as they're concerned, it's just our website that's slow. So we need to think about those things. Okay, now let's move on to the object cache. So the second main cache that's available to us, this is the one that's specific to SharePoint. And as I mentioned before, this is an in-memory cache of queries against the SharePoint repositories. So any query to SharePoint, whether it be cross-list or otherwise, the results of that query are going to be cached in memory, so we don't have to go back and reissue the query later. Now, this is most commonly going to be used by things like the content query web part, the data map provider, which is used to drive the navigation in a site, and so on. Now, the chances are you're already using this because it's always on effectively in SharePoint. There's no knobs and dials we need to tweak here to turn it on. So we're always going to be using this. But we do need to configure in large-scale environments, the size of the cache and how we want to respond to changes. So the size of the cache is fairly straightforward. How much memory do you want to assign effectively for the cache? And the idea here is that you want to have a cache that's big enough to hold the entire contents of the site in memory. And if you have that, you're not going to be missing certain aspects of the site. Now, when I say it needs to be big enough to hold the entire content of the site, we're talking about the SharePoint data here, right? So list data. We're not talking about documents and those kind of things, images, that kind of stuff, right? It's just the SharePoint list entries. So again, we need to make sure we have enough memory on the web servers because we're going to use some of it for the page output cache. We're going to use some of it for this. And we'll obviously use memory for hosting the worker process and so on as well. So this is another reason why the memory on the web servers should not be a small number. Now, it doesn't need to be an enormous number either. For the vast majority of deployments I've looked at, 16 gig of RAM is entirely appropriate. But we don't want to have 4 or 8, anything like that. We're going to hit those barriers pretty quickly. And then in terms of thinking how we configure the changes to the cache, do we want this to be purely time-based? So keep everything in the cache for 24 hours, or should each request check to see if the cache is still valid? And again, this is very much something that we can't really make a broad recommendation on. It very much depends on the content. If your content doesn't change frequently, then a time-based cache is appropriate. If it's acceptable for changes to a product page to have a period of time where you might be seeing the old version of the page, then a time-based cache is appropriate. Fundamentally, every time we check the cache for changes, i.e. we do a cache invalidation, we're going to be doing more work, so more impact on the CPU. And then we also need to think about, do we want to cache more results than the user asked for? Now, this is a little niche. It's really only useful in scenarios where we have different permissions, different security for different items. And that generally is not a good thing to be doing in a WCM site, not just from a performance point of view, but from a management point of view and so on. But it's also something we might want to think about if we're doing paging. So we might have a web part that displays 10 items, and then you click a button that goes to the next 10 items. Now, these are becoming less and less common, mainly because most users never click the next page button anyway, right? If they don't see what they want on the first page, they give up or they try a different query, those kind of things. So the results multiplier is, pretty niche in terms of configuration. It's the first two that are the most important. Now, none of this is going to work properly unless we configure the super accounts. We don't have a very good name for these, unfortunately, or particularly good documentation. But this is the reason why it doesn't work, even though it's on by default. Right? So I've already said this is kind of on by default, but unless we configure these two accounts, it's not actually going to get anything from the cache properly. So we don't have any user interface to configure this. We have to do this via PowerShell. And really all we're doing here is we're configuring these two super accounts, which are kind of hidden in the system, not represented in central admin in any way, and then assigning each of these accounts a policy on the web application. So there's two of them. There's the super user account, which is effectively the administrator in this case. This is going to be the guy that checks for cache invalidation and so on. And then there's a reader account, which is the one that's going to retrieve items from the cache. And so the PowerShell on the slide there shows us we grab the web application that's hosting our site collection, and then we configure a couple of properties on that web application with the account name for each of these. Now, it's very much a recommended practice to use different accounts for each of these. And the reason we want a different account is because we're going to assign them a different policy. Okay, so from a security perspective, we don't want to mix these two accounts up. So we need two additional domain accounts here. Now, that can be quite a contentious point because you've already probably got a lot of accounts in the deployment, and adding another couple to them is potentially going to cause an argument with some administrator somewhere who doesn't like managing lots of accounts. Note that we never need the password of the account here, right? So we don't need to know the password of the account. These don't need to be SharePoint managed accounts, so we don't need to worry about password reset issues. Anyway, once we've set those properties, we then call update on the web application that persists the changes. Now, it's very important that we configure the two properties, the super user and the super reader there on the slide, using the correct format. So if we're using classic mode authentication for the web app, this would be domain/username. But if we're using claims authentication, we have to use the format of the authentication provider, which would be the strange prefix and then domain/user. So if they're mixed up, again, this won't work properly. So once we've done that, we'll then assign a web application policy to each of those accounts. So the super user gets full control and the super reader gets full read. And then once all that's done, then our object cache will actually be having an effect for us. So whilst it's true that we don't need to turn it on, we must configure this for it to, for us to get the benefit. Now, this is what happens when you don't use the object cache. It's our same website. This time the hero controls orange, but anyway, whatever. This is the reason why this happened is because of misconfiguration of the object cache. Now, this little control here, the orange bit, that's actually a client-side code. Okay, so it's Silverlight. And it's implemented as a sandbox solution, which is a good idea in principle, but unfortunately, because that's not leveraging the SharePoint API, or rather it's leveraging a non-cached SharePoint API, we're going to immediately blow out of the constraints of the SharePoint, the sandbox service, right? We're going to overuse resources, and so that control is going to get shut down. And that's good, right? We want unruly controls to get shut down, but we don't want them to be rendering that kind of stuff, right? One of the biggest problems we have with sandbox solutions from an end-user perspective is there's no good way to degrade gracefully, right? There should be a better display than that. But anyway, and this is a very important point. Not all SharePoint APIs are cached or leverage the object cache. And so, if we're using things that do basic list operations, like the bottom of the table here, splist.getItems, that's not going to leverage the object cache because the object cache is a publishing feature. And so we should be making use of the publishing APIs to ensure that we're leveraging the cache. Now, if we do want to do this Silverlight or Flash or Ajax type approach, which is more and more common, especially for the high design-minded views of sites, we need to make sure that we wrap the thing that we're calling in a web service so that we can leverage those cacheable APIs. Okay? We can't use the SharePoint client object model here because none of that stuff is cached. So that's even worse, right? Because we have a client-side control that's going back over the wire to the SharePoint server. That's got considerations in and of itself in terms of performance, but it's uncached as well. So that's going to impact not just the one page that's being viewed, but everything else that's happening on the environment. So we're going to need to build basically a web service that runs on the SharePoint machine, which wraps our execution of publishing APIs. And then we can carry on and build the Silverlight or client-side components the same way that we would normally. Okay, and the last cache is our blob cache or the disk cache. And this is simply a mechanism to store files on the web service front-end disk feature that comes from Content Management Server, in fact. And what this means is there's going to be less rendering work done by SharePoint. So if we download a product catalog, the first user that downloads it will go back to the content database, retrieve the item, cache it on the disk, and then when the subsequent users come and get that file, they'll directly go to the cache on disk rather than going back to the database. And it will also result in less information going over the wire to the end users' browsers as well. We can also use this for media files, so video, music, etc., by having the way the web browser requests those these days is they'll request a segment of the file. And so our disk-based cache actually supports that as well. So unfortunately, we don't have any configuration for this in central admin or site collection settings and so on. This is all done in the web config for the web application. And it's fairly straightforward. We have this line in, and it will be in the web config anyway, but we need to turn it on by toggling the enable attribute there down the bottom to be true. So a couple of other parameters that are important here is the location. So this is where on disk the cache is going to be. You generally don't want this on your system drive. That's a bad idea. You want this on a separate drive so you're not filling up the system drive. And then a pipe delimited list, which is in brackets here, of the file types to cache. So in this example, we've got a bunch of images, CSS and JavaScript, but we might want to add in there PDF, doc, etc. Then we can set the maximum size, and this is the aggregate size, so the overall size in that C blob cache directory. And this is in gigabytes, so we have 10 gig on this one, which hopefully is enough to store all of the things on your site. But again, if you're delivering downloadable video files or PowerPoints from a conference, that might not be big enough, right? So you might need to make it a bit larger. Then the maximum age in milliseconds. So this is how long to keep things in the cache before they're re-retrieved from the database and overwritten. So the longer we can make this, the better, right? Because then we're not invalidating the cache. But again, this value really needs to be determined on how frequently those items will change. And remember that this value is applicable for all of the types. We unfortunately cannot say for PDFs have this max age, but for CSS have a different age. A couple of other points to note on the blob cache is that It works for host name site collections, so that's a bit of an old wives' tale, is that this doesn't work for those guys. It does. But also remember, we have a cache per web server. So if we have 4 web front ends, or sorry, web servers, we'll have 4 different blob caches, and they'll have different content, okay, potentially. So it's the first request to an item on each server, we'll put it into the cache. Can we use a shared folder for this guy, right? Point it to a network folder? No. We could configure it, but that's not supported and it's not going to work properly. If you want a distributed cache, then you need to look at alternate technologies for providing that kind of thing. And to be honest, in a high use site scenario, there's very little benefit to doing that anyway, because in a high use scenario, you're going to have most of the items in the cache on each of the machines anyway, all assuming that your load balancer is functioning correctly. Okay, so that brings us on to content delivery networks. And just want to briefly touch on this before we get on to the rest of the material. Content delivery networks come in all sorts of shapes and sizes. Okay, we have big, enormous service-based content delivery networks like Akamai that you can use, which are usually quite expensive, but will provide a significant reduction in the load on your hosting infrastructure and also support numerous other things like restartable downloads, geographically dispersed caching for worldwide deployments, and also improvements in how many concurrent requests the clients can be performing. So that's one end of the scale for the very, the extreme end of things. Something like MSDN subscriber downloads would use that. Or even something like Ferrari.com may use an external content delivery network. But then on the other end of the scale, you've got, very sort of small content delivery networks which could indeed be installed on the web servers themselves. So something like the Optimized solution could be considered a content delivery network that lives on the web server that's running SharePoint. But also think about things like the TMG cache server capability, which allows you to scale the cache rather than having to scale the SharePoint farm and be able to deliver, vastly more requests per second from the cache than you can from SharePoint. And of course, you don't want to be in a situation where you have 16 SharePoint web front ends, right? Because that's very expensive. Where you might be better off where you have 4 or 5 TMG cache servers and 3 or 4 SharePoint servers. And you get much more throughput for significantly less cost. So the CDN thing is, there's many different types of them, and there's stuff in between those two ends of the scale as well. So they do have quite a lot of appeal, but they're certainly not a magic bullet. If we're talking about offloading blobs, that's the MSDN subscriber download scenario, right? If we're downloading the latest preview of Windows 8, we're probably not going to be storing that, in a SharePoint document library and streaming it back to the clients, right? You want to be getting that from a external service which is much cheaper and quicker. And of course, in the case of MSDN subscriber downloads, it's going to figure out if you're in Europe, you're going to get it from the Europe CDN. If you're in North America, you'll get it from theirs, and so on and so forth. So that's great. You can do more downloads concurrently. The end users get better speed for these large files and so on. This is also very common for video files and even this TechEd website, if we were watching the streaming stuff over the last couple of days, that's coming from a content delivery network as well. But the problem here, of course, is you're trading off those benefits against the ability to manage the content, right? You push it out to the CDN and you lose all of the content management controls and life cycle there. What's more common in SharePoint land is to go more towards the smaller scale and use Content Delivery Network for system files, right? This is very much a quick win or a nice, easy win. So, you know, if you're using client-side JavaScript approaches, you know, you can offload the hosting, if you like, of those libraries to somewhere else. So things like the jQuery or the Ajax Content Delivery Network can be used for those, the Azure stuff there as well. And this is the sort of thing, or one of the things, that solutions like Aptimize will deal with as well. They're not offloading the hosting of those files, but they're minifying them. Now, that's not even a word, but anyway, that's what everybody uses for it. Reducing white space in those files. Now, SharePoint's quite intelligent. We're not going to push back JavaScript that's not needed by an unauthenticated user, but they're still quite large, these JavaScript files and so on. So by reducing these things and doing other things such as image spriting, combining many small images into one image, we can improve the overall responsiveness of the site. But you need to do quite a bit of in-depth discovery here to figure out which is the right approach for your particular deployment. There definitely isn't, you know, one right answer here. In line with that, another thing we can do in a SharePoint environment, assuming that our end users are directly touching the SharePoint environment, is to look at IIS compression. So this is here for us, available for free, obviously because SharePoint's running on IIS. So there's two compression mechanisms in IIS. And I'll skip forward because that screenshot's pretty useless. This is one that we should be looking at. So we have static compression and dynamic compression. Static compression is fairly straightforward. Things like JavaScript files, CSS files, and so on will be compressed before they're sent over the wire. So something like core.js in SharePoint, I can't remember the numbers off the top of my head, but it's something like 300K on disk. We'll compress it down to about 70 or 80K before we send it back to the client. So that's a good thing. And then we have dynamic compression as well. And this means that we can also compress dynamically generated stuff like ASPX, which is our main page in SharePoint. Now, the UI here, unfortunately, doesn't give you all of the configuration options. It only gives us really the ability to turn it on and off and to specify where the cache is on the disk, which is something else we'd want to move, by the way, somewhere else. Static is fairly straightforward, right? It's either on or off. There's a metabase setting that allows us to configure the types of files that go in there, but it's fairly straightforward. And then the location it's stored and how big that location to be. But when we talk about dynamic compression, we need to also consider the impact on CPU, because basically what this is doing is zip compression, right? So that's another expensive operation on the CPU. So with dynamic compression, we want to set a threshold at which to turn it off. Once we've turned this on, it will be running and doing the compression on our ASPX pages. If our CPU hits 80%, we want to be able to turn this off. Okay, because if our CPU's at 80%, remember we're going to increase the latency significantly. So that's the point at which we want to turn it off, so that we're not adding to the performance problem. And then when the CPU gets to a point where it's calmed down a bit, maybe it gets back to about 50%, we want to be able to turn it back on again. And these are the configuration options that unfortunately aren't in the IIS tool. We have to use a thing called app command to configure these things. Unfortunately, I don't have the details in the slide deck. If you want those details, feel free to email me or contact me using these social networking things, and I'll send you a link to the information. Now, the neat thing about dynamic compression is we can also configure it to compress the output before we add it to the output cache. So we're getting the best of both worlds, dynamic compression and the output cache. And again, that's a configuration via app command that does that. So this is there for free. in terms of being able to use it. But again, we need to think about our CPU and disk and memory before just sort of turning it on. You can also configure the level of compression, right? So the aggressiveness of the compression. You definitely don't want to turn that on to 9, which is the maximum, because you're not actually going to get much smaller files, but you're going to get a much bigger impact on the CPU. So a 5, 6, or 7 is the ideal number there. Okay, so that's our caching and associated topics. Now I want to move on to a couple of other feature areas, and we'll spend the last sort of 15 minutes or so on these. For my benefit, how many of you here who are running your website on 2010 are using content deployment in that deployment? Okay, yeah, not many of you, which is good. It's not a bad thing. So just to recap this for those who aren't familiar with it, we have the fundamental concept of SharePoint's web content management capability is the ability to author in place. Okay, so content authors come in, they're looking at a template that looks like the page will look like when it's finished. They edit their content, it goes through some approval process hopefully, and then it's live. And basically what that means is the authors of content and the visitors to the site are in the same site collection, and it's all mingled in together. And that's fine. These days it's perfectly acceptable to do that, right? There's no performance reason why we shouldn't author in place. 10 years ago, well, hang on, a bit longer than that, 15 years ago, it was pretty difficult to actually have this type of environment because you would have to tune the environments for their different usage. Today, with the hardware we have and the software configurability, we can easily do this from a performance point of view. And from a security point of view also, we can do this as long as we configure it correctly. There's no security risk here. However, that doesn't mean that we can sort of ignore content deployment altogether as much as we might like to, because there's definitely scenarios where content deployment or separate environments for authoring and publishing are required. And as the diagram indicates, the authoring is happening in one environment, and then this magic feature content deployment is coming along and pushing stuff out to a different environment for hosting. And that's usually going to be a scheduled operation that's happening, once a day for some content, maybe every half an hour or hourly for other content. So this is just another architecture diagram which basically shows that, we've got an authoring farm, and content deployment is responsible for pushing stuff to the production farm. And we've got search in each farm, and we're leveraging the managed metadata service, that should say, using publishing there. Now, this actually isn't that common because this assumes that our authoring farm and our production farm are in the same organization. Now, the main reasons why content deployment happens, or should happen, I should say, is that there is a regulatory or legal or regional requirement that a user cannot have contributor permissions on the production site. Okay, that's the most common good reason for content deployment. Another reason is simply that the organization for whom the website is there is not in the business of web hosting, right? So if you're Contoso.com, you make widgets, your expertise is making widgets, your expertise is not running a website hosting business. And so you need to be able to do your authoring on your intranet and then have content deployment push the content to somebody like Rackspace who is in the web hosting business. So those are really the only two reasons, good reasons, why you should look at content deployment. I'd be interested if anybody here does have a different one, but these are the two main good reasons why we do this. The one that's on the slide there, reviewing staging all content before it goes live, is slightly tenuous. Content deployment can be used there, but There's other approaches which we'll come to in a second for that. The fundamental thing, of course, here is content deployment is going to add a latency between when the content is approved and when it actually goes live, because no matter how fast our connectivity to the other environment is, it's going to take some time for the content to get moved. And it's directly proportional, of course, to the volume of changes since the last time deployment happened. And of course, if you use content deployment to push out from one authoring environment to 5 different production environments, those 5 different production environments are going to be out of sync whilst deployment is occurring. So why we shouldn't use content deployment? We've talked about why we should. We want to review and stage everything before it's in production. Well, you can do that in place. If this is the only business requirement, then authoring in place is perfectly acceptable because we actually do this. Now, staging, i.e. pushing it out to somewhere, checking it there, then moving it into production, is slightly different. So, having another step, so having 2 approval steps effectively. Very common in old style content management deployments. And usually this is why this is sort of asked for, is because it's how it used to be done with a different system. Then we've got high availability, which is, a totally different kettle of fish. We could have, 5-hour session on high availability. Things like, geographic replication, having the same content in different parts of the world, different data centers, having disaster recovery. These are things that content deployment is not for, right? It's not appropriate for this use. Doing a relaunch or a redesign of the site, again, it's not what this is for. All of these things, those 3 things there that I've just mentioned, we can do quite simply with SQL Server technologies, right? So things like log shipping can deal with these problems for us. Now, the last one there, scheduling the load, what this really means is separating the write operations, i.e. the authoring and approval, from the incoming traffic. And again, that's not something that really we have to worry about anymore, assuming our environment is correctly configured for in place. A couple of best practices on content deployment quite quickly. The first one is, if we can do, we should leverage snapshots. So if we are doing content deployment and we're using SQL Server Enterprise Edition, which is a pretty big if, but nevertheless, what we can leverage here is snapshots. So we're not doing the export of content against the live site. We're doing it against a SQL Server snapshot. And what this will do is, aside from speeding things up a little bit, it won't speed them up that much because export isn't really the time issue here, the time problem. But it will prevent there being a conflict between people doing authoring and the export being run. So this is fairly straightforward. If SharePoint is running on a farm, if SharePoint is running on SQL Server Enterprise Edition, we will have an option enabled for us in the job configuration here, to automatically create and manage SQL Server snapshots. What this will do is it will create a SQL snapshot, it will run the export against that, and then it will clean up the snapshot for us. So we don't have to worry about going into SQL and cleaning things up. The second best practice is really a must. Right? Our custom solutions must be aware of content deployment. We see this over and over again where the content deployment stuff is fine, but there's a custom solution in there that's causing problems. And we have to make sure that our custom solutions are aware of content deployment being in the mix, because otherwise, if we have, say, something that is a solution and that's responsible for creating a bunch of list items, when the content deployment runs, that's activation of the solution is going to fail. So I've got a little snippet here that basically shows at a very high level, you don't have to do anything, it's not rocket science here, it's very straightforward. We simply leverage the content deployment import context class and check to see if it's running, and if it is, don't do whatever you were going to do. And if it's not running, go ahead and modify the object. So it's fairly easy to do. It's just something that generally speaking, people don't consider or forget. Also remember that we have caching in play, and our profiles and cache settings are deployed as well. So if we want different caching in production, as we have in authoring, we can use profile overrides. And this is a snippet of the web config necessary for that. Okay, so the last topic, we leave the best till last, as it were, is variations. Anybody using variations? A few of you, okay. Similar kind of numbers to content deployment. So again, this is a topic area we could easily spend a whole session on, but for a few sort of best practices for scale here. The first one is fundamental, is not to try and bolt multilingual on afterwards, or what the product group refer to as multilingual afterthought syndrome. Now, this is actually much less common in Europe, unsurprisingly, than it is in other parts of the world. But the scenario is, we know we need multilingual at some point, but we haven't got time for it now. We'll do English first, and then we'll add some extra languages later. It's not going to play. It's going to be a disaster with SharePoint. Fundamentally, if you need this, whether you're using variations or any other approach to multilingual, you must plan for it up front because it impacts everything about the deployment. Also, if you are using variations for it, if you then come along later and turn it on, there's a huge amount of content that's going to need to be propagated from the source, which is the existing content, right, which could be hundreds of thousands of pages and associated resources, to each individual variation label. And the second one is to consider a feature called on-demand page propagation, and I'll come back to that in a second. Oh, here we go. So by default, when we configure variations, it's automatic, and when we approve changes, those changes are propagated to the variation sites. Now that's great the first time you do a page. Let's say we go ahead and edit this page here that's in the English, or rather the American website there, and we have one a variation added for us as we approve that English version. A French one is created. Well, that's great, but what happens if that English page had a spelling mistake in it? Okay? Now, when the content author in the French site came along and did the translation, they would have fixed that up anyway as part of the translation. They would have noticed that it was misspelt. They would have ignored it and just done the translation as appropriate. It might have been a typo that they fixed up. But if I then come along as the author of the English version of the page and correct that spelling mistake, the system is going to automatically overwrite the previous translation. Okay, with that, just because of maybe a one-character change in the page. So that's where the on-demand propagation comes into play. Forget the animation. It's got no relevance to what I'm talking about. It's just a architecture animation. Anyway, so we have the ability to, what we could do is turn off the timer jobs, but that's not a supported change and is actually going to cause us all manner of problems later on when it gets turned back on, because then we're going to have a ton of propagation necessary. So what we can do is enable on-demand propagation, and what this means is the end user will be, or the author will be responsible for basically saying whether this requires propagation or not via a ribbon button. So we do this via PowerShell. It's not in the user interface. It kind of came a little late, so there's no UI for it. But we'll basically grab a hidden list, a special list in our site called the relationships list, and then set a property called disable automatic propagation on that list to true, and then update the folder. So it's fairly straightforward. And then once we've done this, there's a button on the ribbon in the authoring environment which allows the user to specify whether propagation should occur. Now, the last topic is the variations fix-up tool, which has been around for quite a long time. It was around with SharePoint 2007. but it's still here and still useful for us because our timer jobs that are responsible for doing the variations work are very intensive and sometimes can be very long running. So if we're in a very large-scale site with many variations, whether we're using it for multilingual or other things, this tool allows us to do sort of out-of-band operations and repair broken relationship assumptions and also do things in a more manageable fashion. So this is a STS-ADM command. So, in summary, we're just about out of time. Really, hopefully the takeaway has been, or the information has been useful. You can take that away and avoid being in this kind of scenario and getting this email from your corporate vice president, which is pretty embarrassing. As well as it being embarrassing, obviously, you know, it's bad for the customers and bad for your brand. So hopefully it's been useful. Feel free to follow up with me via email and so on if you have further questions. I'll be around for the next 15 minutes or so before the next session as well. Thank you very much.